All right, welcome back to Prep for Calc. What do we got from yesterday? Right, graphs and functions. That was the unit section. Right, defining set for a relation. A relation is a set of ordered pairs, I believe. And defining domain and range for a set, you basically, for domain of a relation, it's a set of the first elements of the ordered pairs, and the range is a set of the second elements in the ordered pairs. Domain, range, okay. Relations, determining whether a relation is a function. This is basically seeing if any of the first elements appear more than once and have more than one second element. Basically, it's the vertical line test. If it's graphically, it's looking at, is there one input that has more than one output? If so, it's not a function. One of them was like evaluating absolute value, rational expression, square root expressions, simple, function. All right, that's definitely three. Unions and intersections of sets. Easy. Union is simple as U. Intersection is like an upside down U. And an empty set is a 0 or an O with a cross through it, a line through it. That's intersections. Unions, finite sets. Domain range of ordered pairs. Domain range of ordered pairs. Domain range of relations. I thought. Transforming the graph over the axes by reflecting over the axes, and identifying functions for relations. So that's it from yesterday. I'm gonna jump back in because e-learning, and I'll be back to recall what I learned in a little bit. All right, as per usual. I ripped through multiple topics. First is we finished up what would have been radical expressions. No. We finished up functions and graphs yesterday, I think. And we started radical expressions today. So multiplying radical expressions, we already learned how to do that. Basically, the square root of a plus, or a times b equals the square root of a times the square root of b. Radical expressions. What was the other thing? Two more topics. Odd root property. So basically, okay. Before that, writing, like converting between exponential form and root form, radical form. Basically, like square root equals the same thing as like the square root of x equals x to the 1/2 power, or the cubed root of x equals 1/3 power. The cubed root of x squared equals x to the 2/3 power, etc. And then the odd root property. So odd root property is talking about the root of an odd number, not the root of an odd number. Like square root's an even root, cube root's an odd root, the fourth root is an even root, fifth root is an odd root. So like an odd root power means it's going to have exactly one root rather than two. Even has two because it's plus or minus. So the odd root property basically saying there's one root, and it also, the number you take the root of can be negative because it's odd. unlike there's no negative square root or fourth root, etc. A real number, this is simply a way to think about it for me is like a number that's not imaginary or complex, just like a normal what you think about when you think about a number. Um, so that was radical expressions. Finish that up. Then we start talking about lines and systems. I don't know why linear systems would be. I missed these. I don't even understand how this got marked wrong. But the first was basically given 2 points, find another point on the line. Simple enough. You set up the two equations, solve for them. And then the second topic is, I haven't finished this one yet, but it's basically like time, rate, distance problems with linear systems. So you're like, the example was a plane flies in one direction. This is the rate. Flies in the opposite direction. This is rate. What's the rate of the airstream or wind, etc. And what's the rate of in a with no airstream, like no wind. All right, solving distance, rate, time problems using a system of linear equations. Finding a coordinate given 2 points. Converting between radical form and exponential form, exponent form. And then solving an equation using an odd root property. And square root multiplication. So that's it for today. We probably will finish the first pass of the rest of the topics tomorrow. So, yep, that's it for today. Talk to you tomorrow. See you.